right, well, we are going to do a review in this lesson of slope. And if you'll remember, slope comes into play when we are working with linear equations. And so linear equations or linear functions. And that takes the form y equals mx plus b, where m is always your slope. And so hopefully you can recall that slope is the change in the line as it progresses along the graph. So slope is always our change in our y coordinates. That triangle means change. So change in the y coordinates, and we put that over top of the change in the x coordinates. So the change in the y coordinates is the difference between the two y coordinates that we're talking about. And we also call this rise. And then the difference between our two x coordinates that we're talking about is called our run. So we're talking about, when we talk about slope, rise over run, we're talking about how fast or slow, the rate that the line goes up and down. And we compare that to how quickly it runs left or right. So it's rise over run. We call it change in y over change in x. And all of these things are discussing and describing really how the line is moving in the graph. So we need to just do a quick review using number 1 over here of how to actually calculate the slope. And so remember, if you're doing change in y, that means we're going to take the difference of these two y coordinate points here. I could say 1 minus 9. Or I could do 9 minus 1. It doesn't matter which order I start, but in whichever order I begin, I have to actually finish up with my x's in that same order. So because I started with the first point, when I wrote my 1 down, I need to start with my first x point when I write my x's down. So I'm just finding the difference. I'm finding how this line runs over how it rises over how it runs. All right, so we'll end up with this one having a slope of 2. So this is a positive slope. That means that it's going to rise from left to right on the graph. If we were to have the function and be able to graph it, that's what we would see. Okay, so that's one thing we can tell from the slope of a line, whether it's going to rise or as it moves left to right, or it's going to descend as it moves left to right if it were negative. So the other thing we can tell when we're working with these slopes is which line is going to be steeper. And by steeper, we mean which one is going to rise quicker. So this is just talking about the rate of change. All right, so that's all slope is a rate of change. How fast it's going up as compared to how fast up or down as compared to how fast it's going right or left. So if we want to know which one of these lines is steeper, we need to calculate the slope for each one. So I'm going to call the first slope for line 1, I'm going to call it m sub 1. And I'm going to do the same thing. I'm going to take the change in y's. I'm going to start with my first y, subtract the second y, and then I'm going to put that over this first x coordinate and subtract it from the second x coordinate. And so I'll end up with negative 1 over negative 6, which those two will cancel out to give me a positive 1/6. And then my second slope, 3 take away 4 over 2 take away 6. Will give me a negative 1 over negative 4. Or positive 1/4. Right, and then after we have both slopes calculated, we're looking for which number is greater, which is the larger number, which obviously 1/4 is bigger than 1/6. So the line that is steeper is line 2. If we move to the back of the page, they ask us to find the slope of the line passing through the given points, and then tell whether the line rises, falls, is horizontal, or is vertical. So we're going to calculate the slope first in the same manner that we've done for all the other ones. We'll subtract the y's, subtract the x's in the same order in which we subtracted the y's, and we end up with a slope of 1/4 there for number 11. So because this is a positive slope, 1/4 is a positive number, that means that this line is going to rise. Okay, so this is, we're talking about right to left when we're on the graph. So if we were to graph this problem, it would take a path that would go up this direction. Okay, the other option in for this kind of a problem is that the slope would be negative. So let's just say that we did the math here and we ended up with a negative 1/4 instead of a positive 1/4. If we're negative, the negative slopes always descend, okay, or what they're calling is falling. And again, we have to be reading the graph left to right in order for this to apply, but that would look like a line that descended as we went from left to right on the graph. In number 12, we have a little bit of a different situation in that once we calculate the slope here, we end up with a 0 in the denominator. Okay, we cannot divide by 0. Remember, that's not allowed, and we can't. And you can think it through. Really, there is no way to divide any number by 0. It just doesn't even make sense. You can have 0 in the numerator. You can divide 0 by another number, but you can't have 0 in the denominator. When this happens, we call it undefined. But as far as the graph of this function would look, it would be a vertical line. So it would be a line on the graph that ran perpendicular to the x-axis top to bottom. Okay, so this would be, as far as telling, according to this problem, they asked us to tell what the line does. This would be a vertical slope, although we don't exactly call it slope, it's because it's really undefined. If we ended up doing one of these problems where we're calculating the slope and we get a slope of 0, so if m ever equals 0, then this is a horizontal line, and it means that the line is just running through some point on the y-axis in a horizontal manner. It would be completely horizontal, completely parallel to the x-axis. Now, moving down to 17 and 18, we're going to calculate the slope of the two lines with the purpose of deciding whether they are parallel, perpendicular, or neither. So let's go back to those definitions of parallel lines. If you have two parallel lines, that means that they are running in the same direction for infinity, but they are never going to cross. Okay, so parallel lines will never cross, but they are running the same direction with the same slope. So parallel lines always have the same slope. Perpendicular lines are going to come in and meet each other at a right angle. So they'll cross one time, and that will be at a right angle. Their slopes are going to be the opposite reciprocal of each other. They're going to be opposite reciprocals. So for example, opposite reciprocals. For example, if the slope of line 1, let's say your line 1 slope was 5, your line 2 slope then would be the reciprocal of 5 and the opposite of it. Okay, and vice versa. 5 is the opposite reciprocal of negative 1/5. All right, so if we go to number 17, our first step then is to calculate both those slopes. Okay, so we'll subtract the y's, put that over the difference of the x's. We'll end up with negative 3 over negative 9, which is a positive 1/3. And then we'll do the same thing for that second line. 1 minus 0, 4 minus 1 equals 1/3. So we have a slope of 1/3 on the first line as well as on the second line. So that would make these two lines parallel. All right, we'll try number 18. I'm gonna come down here with a new color for number 18. The slope of that first line, 3 minus 7, change in your y, or you're changing your x, and you'll end up with a positive 4 for the slope there. Line 2, negative 4 minus a negative 5. Watch those negative signs when you have those, when you're subtracting these negative numbers. Make sure you don't lose a sign there. All right, so 1 over negative 4. I'm just going to rewrite it as negative 1/4. So here we have a situation where they are opposites of each other and they are the reciprocals. And so in this case, line 18, these would be perpendicular. Now the other option there they spoke of was neither. So in order to have neither perpendicular or parallel lines, it's just like any other situation. I mean, if the slopes are not the same, that means that they're not parallel. And if they are not opposite reciprocals of each other, then that means they're not perpendicular either. Then they are not parallel or perpendicular. They're just two lines that run in different directions and at some point will cross, whether we can see it on the little graph that we're going to make or whether it would be off somewhere in the distance on the graph that we may not ever see because we wouldn't make the graph that large. All right, so they're either parallel or perpendicular, but if they're neither one of those, then that just means they have different slopes and completely different slopes. Okay, so moving down to the two word problems at the bottom, 21 and 22. 21 is about fuel efficiency. On Friday, you left for a weekend camping trip. You had 110 miles on the odometer already, and you had 14.5 gallons of gas in your tank. Oops, did not mean to make that large. When you returned on Sunday, the odometer read 299 miles, and you still had 7.5 gallons of gas left. What was the fuel efficiency of your car on this trip? So this is a rate of change. This is another a more practical application of slope. So our rate of change in a car when we are traveling is how many miles are we able to travel on a certain number of gallons of gas. Okay, so this we would call kind of in this kind of problem if we were going to graph a linear function to show the relationship between the miles in our car that we travel and the gallons in our gas tank, this would be our slope. Okay, so that means that our miles are reflective of our change on the y-axis when we would graph it, and our gallons are reflective of the change in x. So we can think of these two, all this information as just points on a graph. If I were going to take this information and put it into 2 points that I would graph, my x coordinate would be 14.5 gallons for that first point and 110 miles. Right, my second one would be 7.5 and 299. So we're going to look at the rate of change based on where we started on the odometer and the gas tank and where we ended up. So we can find our slope here, or our rate of change. We would call it our rate of change in this problem particularly because we're working with a word problem. So I'm just going to subtract the y's, and I'm going to put that over the x's. And I'll end up with 189 over 7, and that comes out to be 27 miles per gallon. All right, so fuel efficiency just means, again, how far can your gas tank take you with a certain number of gallons of gas in it? How many miles can you go? That's your fuel efficiency. All right, and on this last one, you can actually see the word rate in the title of the problem. So we're looking here at production rates. So we're going to look at the rate of change in your work, the production rate, how fast you're working in this problem. When you started your shift at 7 a.m., 120 steel valves had already been machined and were ready for assembly. At 3 p.m., your shift ended, and 424 steel valves were now completed and ready for assembly. The target production rate is 36 steel valves per hour. What was the production rate for your shift? Would your supervisor be satisfied with the work pace? So this last question right here, we need to wait on, and that's until we know and have calculated our production rate. This is the 36 steel valves per hour is our goal, but we can't use either of those things until we've actually gone ahead and solved for the production rate. So again, we're talking about the number of valves that have been completed and ready for assembly per hour. So that's our rate. We can figure out how many valves we have completed by looking at the numbers. That when we left our shift, there were 424. When we got there, there were already 120. So we're going to subtract the two of those to find out how many we did on our shift. And our shift here is 7 a.m. to 3 p.m. Now this is a little bit different than the one above because we don't want to subtract 7 and 3 here. We won't get an accurate count on the hours. That would give us 4 hours, but it's really going to be 7 to 12, which is 5 hours, and then noon to 3 there is another 3 hours. So we worked 8 hours in this shift. So we want to make sure we calculate that correctly. That one just takes a little bit of a different twist on it. All right, 424 minus 120 gives us 304 valves that we completed in this 8-hour shift. So that means that our rate of production was 38 valves per hour for every hour. Now we can go back and answer the last question, the second one. Would your supervisor be satisfied with the work pace? Well, we go back up and see that the target that the supervisor wanted us to hit was 36 steel valves per hour. So we could say, yes, we actually exceeded that goal. And so, yes, the supervisor would be satisfied with the work pace. All right, so when you do your textbook homework on this section, on 2.2, when you do that and you get to those word problems, make sure you come back and revisit this so that you can kind of get that idea of how we use rate of change and slope, the idea of slope in these word problems.